Right, let's have a go at this first example. So you can see the question there. A blob has a force of 4 newtons acting on it to the right and 3 newtons upwards. Draw a scale diagram to work out the size and direction of the resultant force. So quite simple numbers there, 4 newtons and 3 newtons, and you can see the squares here. So I'm going to go for one square representing 1 newton. And I'm going to start by drawing my blob down here. Now I'm using a pen, but you should always draw your diagrams in a pencil. I'm using a pen just so that you can see it more clearly on the video. So 4 newtons to the right, so I'm drawing a horizontal line 4 centimetres long to the right. I'll just note my scale down there. 1 centimetre equals 1 newton, in case I forget. And then I've got these 3 newtons upwards, so I draw a vertical line 3 squares up with the arrow on the end to show it's a force. So there's my free body diagram, and I'm going to complete it to work out the resultant force. So remember, let's label those 4 newtons, 3 newtons. So remember, we nose to tail our forces, doesn't matter what order. So I've got my 3 newtons up, and I can add a horizontal 4 newtons onto the end of that. I've drawn it dotted to show it's part of my construction, my working out lines. Similarly, I can go 4 across and then 3 up, and that'll get me to the same point. So just make sure I'm drawing it accurately. And now this point here, that top corner, that is the end point of my resultant force. So I can draw my resultant force from the centre of the blob to that end point there. Nice clear resultant force, and we usually put a double arrow on there to show that it's the resultant. Now we were asked to work out the size and direction, so we'll measure the length of that resultant force, and you can see there that it is 5 centimetres. So the resultant force is 5 centimetres, which represents 5 newtons. And this angle here, you can measure with a protractor. There we go. So looking on our protractor, there's a line that looks like 36 degrees. So we say at 36 degrees to the horizontal. Okay, so we'll go straight on to example 2 now. Okay, so instead of a blob, we've got a ball now. There's a downwards force of 60 newtons and a force to the right of 25 newtons. So our diagram's going to go down and right. So I'm going to start in the top corner here. Now I want to get to 60 newtons. Obviously I don't have 60 squares, but let's just see how many I have to choose a sensible scale. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times 5 is 60, so 12 squares will represent 5 newtons each. There we go, so you can see it on the ruler as well there. So again, you'll be using a pencil. So if you make any mistakes, you can rub them out. Now, I asked you to draw these as we went along. I realise that you won't all have squared paper at home. Great if you do. If you happen to have your maths book, you could steal a page of that. If not, just draw them roughly to scale and label them so you know how you would do it. So that represents 60 newtons downwards and a force to the right of 25 newtons. So remember, our scale for this one is 5 newtons is 1 centimetre. So that will be 25 newtons divided by 5, that's 5 squares. So there's our 25 newtons to the right. Now we're asked to work out the resultant force, so we can add them nose to tail. So to that 25 newtons I can add 60 newtons downwards, And again, I'm drawing it with a dotted line, so it's clear that it's construction lines. And I can also do nose to tail 60 and then 25, which will end like that. So there's the end point of our resultant force in the bottom corner there. So now we can use our ruler to join from the object to the end point of the resultant force. Nice clear line. And we put the double arrowheads on it to show that it is the resultant. So now we have to measure it to see how long it is, and we have to measure its angle. So remember, 1 centimetre represents 5 newtons this time. So you can see there that that is 13 centimetres. So resultant force RF is 13 centimetres, which means it is 13 times 5, which equals 65 newtons. Okay, so just slightly larger than the downwards force. And the angle, at an angle of, let's get that protractor. So from the horizontal, that looks like 67 degrees to me. You can see 60 and the 70, 67 degrees to the horizontal. At an angle of 67 degrees to the horizontal. Now if you've done bearings in maths, you could use these angles as bearings. So you could say like a bearing of 071 or whatever it is. But it's fine to say how many degrees to the horizontal or to the vertical. Now looking back at this one, look at our numbers, 3, 4, and a resultant force of 5. And in example 2, 25, 60 and 65. Now you might not recognise this group of numbers as being something you recognise from maths, but you probably recognise the 3, 4, 5 triangle from your right angle triangles in maths. So I did actually deliberately choose nice round numbers. You could check your answers using trigonometry, sines and coses and things like that. However, in GCSE physics they will never require you to use trigonometry to work out your answer. You can use it certainly to check your answer, but they'll never require you to use it to work out your answer. If they tell you to use a scale diagram like this one, then you get marks for drawing the diagram. If you don't draw the diagram and you use trig instead, then you won't get the marks. That's the end of these examples. Let's move on.